Hello guys, welcome to another episode for this poker thing we're doing. So what we're going to be dealing with in this episode is what I actually wanted to do in the last episode but got sidetracked, and that is to handle the problem where you might have multiple cards that have the same number. So example here, 7 of diamonds, 7 of diamonds, and I want this error to be highlighted. So the way we can do this is that we can easily look at the numbers that we generated, and this is 207, 207. There's obviously a error there. Now, let's go ahead and try to figure this out. By looking at the system, the way we have set it up, and remember these blocks, which could be sub-VI. So for example, this block could be a sub-VI, but in my case, I like doing it this way. Obviously, every person can do it however they want. I believe and I highly recommend use sub-VIs and use projects to organize yourselves. But I like having everything in one big block system so I can see it all at once. I just find that beautiful, the complexity and simplicity. So this is super simple. We have 4 blocks, literally, that's it. So if I were to write this on a piece of paper, this would make a lot more sense. There's some clutter, visual clutter, but basically I'm getting the card inputs right here. Then here I'm checking if they are defined or not, and I'm converting them into a unique number. And then here is the reset system that we added, and then here's the card output. Problem solved. Very simple, very fast, very effective. Now let's go ahead and look at what we need to do here. What we need to do is we need to check if there's if any one of these has more than 1. Since this is a unique number per card, that means there cannot be more than 1. And there's only 7 numbers, which makes this super simple to do. So basically all we need to do is create a for loop where we're going to input each one of these. Now these are coming in one number at a time. Now all I would like to do is get an array. I can do this in many ways, by the way. This is the way I'm choosing. I want to search the 1D array since it's only 7 numbers. It's not a big deal. And the array I want to search is the original array. So disable indexing. And I want to search for whatever number is selected in here. And obviously I'd like to output this data as an array right here, create an indicator to show you guys what we're gonna get. So now we're gonna get this done 7 times, obviously, and each time it's gonna check to see if it's gonna check to see where it found this number. I'm not sure if this is gonna work actually. I thought this would give us, for example, on 207 it would give us 2 and 112, 11112. I'm not sure. Oh, there seems to be an error. I'm gonna pull up the help here. Oh, that's the start index. I would like this here. Let's see if this works. Okay, so this kind of worked. And the reason I say kind of worked is because, as you can see, there's 2 2s in here. So it's not exactly the way I wanted it to be. But let's see if there's a count option in array. Search, split, max, reshape, build, sort. I do not see a count. We can do many things. Let's see. No. Transpose doesn't help. Yeah, so according to what I'm seeing here, none of these are gonna actually help us. We could sort the system, or we could just do another head count. So basically now what we did, essentially, we converted this to numbers which should be 0, 1, 2, 3, 4, 5, 6. That is what we should have. So all we need to do now is, I'm trying to figure out, so this is the key, is that this number 2, which is 207. I'm not sure what to do here, guys. if we take each one of these and if we do it the way I want it to, so this is giving me the index, which is in this case 2 for this one and 2 for that one. Well, how about this? If we take the output number and subtract the I number, this new number should give us a unique non-zero number when there is an overlap. So there we go, there's an overlap right here of -4. And that is exactly what I'm looking for. Let's go ahead and run this continuously. Set this to 7 of diamonds. We have 2 numbers here. Set this to 7 of diamonds. Okay, what if I set this to 7 of diamonds? Then all these will change, but I hope that this is clear as to what is going on here. So, very easily now we know that this number is the number that we care about, and those numbers will always be negative. So if this number, let's see, if the number is less than 0, if this, okay, more space needed, we check if this number is less than 0 or not, and we output that. Create indicator again. Now we have a 7 number indicator, which will tell us whether it is repeated or not. And now here, as you can see, it only shows us, it does not show us this one, because this was the original one that is not, we're not sure. So all these are basically referring to this one. So what I need to do is I need to add a secondary way of detecting whether it is there or not. And that method should be to detect in the system after itself. So it's searching, in this case, it searches the 1D array for itself. What if we search starting at the index +1, and this is going to completely change how we're doing this. If we do it this way, guys, what happens is it will not work, because, okay, the reason this will not work is because if I do this as +1, therefore let's look at this. So the first one looks from here on, doesn't find it. Second one looks from here on, doesn't find it. Last one, each one is only going to find it if it is after it, not if it is before it. So if I were to run this and get rid of these two here, so this 207 will detect another 207. Oh, this could work. While this 207 will detect the first 207. Oh, this could actually work. So we're going to have to do this twice. First time, we do a straightforward check from the beginning till your point. And the second time, we do a check from the +1 perspective of this. Now I'm not sure what this is gonna output, so let's see what this output will be. Again, I love using indicators. I find it the best way to program. I'm not gonna say best way to program, I'm sorry, but I find it very helpful to understand what's going on. So what we get here is -1, 6, -1, -1, -1. So what we're looking for here is one that is above 0, right? Because -1 means it didn't find another. 6 means it did find another. But as you can see in this 207, it did not find one. So what we're looking for here is the opposite of here. Here we looked for less than 0. Now we're going to look for greater than, ooh, could it be equal to 0? Let me see. If this was 7 of diamonds, no, why is this not updating? Is the system stuck? Something has gone horribly wrong and I'm not sure what it is. Why is this not updating? Reset. The system is stuck somewhere. Let's put on the light and see what is it trying to process. There we go. Processing the system. Okay, turn off the light. Let it go a little faster. It is not updating. What is going on here? Alright, let me try to figure out what's happening here and get back to you guys. Alright guys, so I got it to work again. I'm not sure. I think it was just my computer was hanging or something. So as we can see, even if it's the first instance, even if I set them all to this diamond 7, then this will detect 1, which is greater than 0. That is what I wanted to test here. So whatever I do, it is greater than 0. Perfect. So now we do a comparison to find one that is greater than 0. And if it is less than or greater than, or, where's our or? There it is. So if it is less than 0 in this case, or greater than 0 in that case, either way, I would like it to be lit up here. I'm going to convert this from this horizontal system to a vertical system, and that way we should be able to see the light bulbs. Hopefully they will match up. No, they did not. Let's see if I can manipulate that. No, not letting me do that. Make this a little bigger. That's way too big. Okay, doesn't matter. We'll get it's not really an issue. Well, it is an issue. I find it annoying. Alright, so there we go. Let us go ahead and run this continuously. So now it finds errors everywhere. This one is no longer the same. This one's not the same. This one is different. Aha! But you see that? 5 diamond, 5 diamond. I actually set up my own mistake here without even realizing it. But that's exactly what I wanted. Now I have 2 jacks that are an issue. So now all I need to do is take these lights and have them inputted into the system. So let's go ahead and see how we can do that. An easy way perhaps to do this is to simply, let's see what we have here. If we take in this exact same input and repurpose it the exact same way to do the output of these directly into the true or false here and update this line by itself. Would that work? Check if card is fully defined or not. So this checks if a single card is fully defined. Can we do this here? No. The reason we cannot do it here is because we need all of these to be processed first. So I'm going to go ahead and make this more compact. But to explain what I just was thinking is that we just basically take this input. Do we take it in one by one? Yes, we take it in one by one. We can basically open it up and then recompile it at the end here, and we can recompile the exact same thing and get it out from here, and this would go back on its way all the way here, break that point. There we go. This is basically what's going to happen. It comes in here. This, when you connect the top part into a cluster, that means everything stays the same unless I change it. So in this case, if this or this is true, and I'm gonna add this at a third OR, even though I could do the following. I could add a compound OR. So basically what a compound OR does, change mode, just or. So if this initial one or this or that, then update it here. I'm just thinking right now of how simple or complex it is to do this. It is not. I'm going to put this here closer to the system. So if it's this or this or this, if any one of these is true, the reason I do this because this could be a true from before, right? And I would like that to be reflected into the system. I don't want to change this true or false, so that's why we have to include this one. And then all the rest go through happily as if nothing happened. Since it's only 3 numbers, I'll do it this way for saving space later on. So we just take this closer up, and there we go. You can actually do it as close as this. There we go. This is the simple system, the way it works. Now I don't actually need this anymore because right now, when I run this, the ones that match are going to light up. There we go. So I have repetitions on these. They are wrong because I have 2 7s. Oh, now I have 3 jacks. There we go. Now I have this. Oh, now I have 2 4s. Now I have 2 9s. Basically 2 kings. So if I change the signs here, this should become much harder to get it to mess up. Oh, found one. There, king, can't have 2 kings. Blah, blah, blah. The system works. Everything is great. Alright, so I'm going to end this episode here. Actually, I'm going to go ahead and simplify this, make a block out of it, show it to you guys, and then end the episode. I'll be right back. So there it is as a block by itself. I just need to still add the... Oh. There we go. Yeah, so I just need to add the title the way I usually do it. Hopefully this does not really annoy anybody, but there it is. There we go. And now, so what are we doing in here? This one, we know that this was check if card is full. This is basically check if any 2 cards. So check if any 2 cards are identical. So that's what this block is doing. Checking if any 2 cards are identical. Hopefully none are, but just in case, there you go. This is the array of the numbers, which I'm gonna keep for future reference. We'll probably still need this at some point. And I'm going to go ahead and move the blocks along. Get this, this, and that moved over here. Just in case. There we go. So, let me get rid of the help. This is our system right now. Basically, get the input, check if every card is defined by itself, convert it into a unique number. Then we use this number basically, and we check if any of the 2 cards are identical or not. If they are, it gives you an error. Reset all the cards, card output, we are done. Here's an array of everything. Now, it has occurred to me that we might need later on an array of true or false, which we can just output from here. But I'm going to wait till we get a finalized true or false array to use. Basically, the reason I'm saying this is because later on, I don't want the system to process data until, for example, all of the, let's say we have the hand, we opened our flop, and we messed up on the flop. I don't want it to start processing the data based on this. I want it to wait till it's correct, then process the data. There we go, and we'll probably get that true or false out of the system from over here. Let's go ahead and do that now. I don't think there's any other error that we can possibly encounter at this point. So I'm going to create an indicator for this and give it a label, and this is basically check if any 2 cards are identical. well, I'm not sure what to call this. This is an error status, basically. This is the green light, if you will. So this gives me the error status on basically all of my numbers, which I have back here. 1, 2, 3, 4, 5, 6, 7 of them. Let's run. Everybody is a go. And oh, there's an error. Blah blah blah. Fix the error. Error fixed. We can move on. We can dissect this later on as necessary. For now, I'm just gonna call it error status. We can fix that later. So convert card selection to unique number. We can actually input that into here and have it output as a cluster. We can do a lot of things. Alright, so it seems that this is it for this episode. Can't see anything else we would need to do. So I will see you guys in our next episode where we continue on with this system. See you then.